So, question 28. Like I said, the key to this question is independent. And what does independent mean? By itself, stand alone. Doesn't have anything to do with each other.
No.
So, looking through the 4 choices, Brian never sleeps 8 or more hours on days that it's not raining in the morning. The probability that Brian sleeps 8 or more hours is the same whether or not it's raining in the morning. The probability that Brian sleeps 8 or more hours is influenced by whether or not it's raining in the morning. The probability that Brian sleeps 8 or more hours is the same as the probability that it's raining in the morning. Which one shows that they do not affect each other? They're independent.
B.
It is B. It is B. B. Independent means they're completely separate. They're not going to affect each other. Dependent means they will affect each other. They will affect. So that's number 28. Next. So this one, I had 2 different rectangles. And the key here is similar. So I have to figure out these 2 rectangles are similar, and whether or not they are or aren't will answer the rest of the sentence. But first I have to determine, are they similar? So are they similar?
Yes.
Why do you say they're similar?
I said they're similar because their corresponding sides are both congruent. Like, if you look at it, you can tell that it's like, if you cut it in half and like in a quarter, you can tell. Like 6, 3, 7.
So this is the short side. This is the short side. So from this short side to this short side, what happened?
Nothing.
I went from a 2 to a 4.
Yeah, it changed about 2.
Say it again.
It changed about 2.
It changed by 2, but remember when you're looking at similar, you don't ever think add, subtract, you think multiply. So what did you have to multiply by to get from 2 to 4? 2. 4 is the big side, 6 is the big side. So did you multiply by 2 to get 6? No. So when it's similar, you have to think multiply. Because proportional things are multiplied things. Proportional things are multiplied things. So rectangle ABCD is not similar. It's not similar. So when I come to the other questions here, anything that says similar we know doesn't work because it's not similar. So this said it's similar, similar. Corresponding sides are congruent. No, I mean they weren't congruent triangle, rectangle or anything. Corresponding sides are not congruent. Yeah, that's true, but that doesn't really tell me if they're similar or not. That doesn't really help me. Corresponding sides are proportional, corresponding sides are not proportional. Well, because they were not proportional, it was not similar. Because remember, similar means proportional. Similar means proportional. Then it says rectangle ABCD can or cannot be dilated to fit over rectangle PQRS. What do you think? It can or cannot?
It can't.
Same things are similar, and the same things that they can be dilated is kind of meaning the same thing. Because dilations means you're growing the same amount all the way around. Well, we already said that it wasn't similar. We didn't multiply by 2 all the way around. So therefore, it cannot be dilated because I can't just multiply by one number and get the new figure. So similar and dilation goes together. Similar and dilations go together. Because if something is dilated, there are similar figures. So that's that one. This question. Now, most of the questions that we have done have been one pointers. We have K, P, Q. Those are the three answers down there, but if I made it small enough so you can see those answers, it would be really small. Now, this one's a 2-point. You get 1 point for figuring out the K. You get another point for figuring out the P and the Q. So it's a 2-point. Now, let's just think of K first. K refers to, says the factor K with a center dilation at point A. So K refers to the dilation factor. So without doing anything else, I can figure out how much did the triangle grow without doing anything else. So that way I can get 1 point. So this triangle here, 3, 4, I mean, I might be able to figure this out, but I'm not even that worried about it because I've got a 3 and a 4 so far. This one, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. So I had this triangle to begin with. They did a bunch of stuff, and I ended up with this triangle. So how much did they grow the small triangle to get to the big triangle? What was my dilation factor? What was my dilation factor? How much did it grow by? What did it get multiplied by? Because remember, dilation is always a multiplied type of something. So what did they multiply by to get to the big triangle? 2. It was 3. It went to 6. It was 4. It went to 8. So this triangle to this triangle is a dilation factor of 2. So it's a 2. Without worrying about anything else on here, I can figure out the 2. Now, let's take a look at the rest of it. I'm going to erase this. It says, first she rotated triangle ABC 180 degrees around point A. So we had this triangle here. If it's around point A didn't move. So she took this triangle and spun it. So we went from here to here. So this triangle is now spun to there. So I know a lot of the rotations we did on the one papers was spinning it around the origin, but this one we didn't spin around the origin, we spun around a point on the triangle. Then it says she dilated triangle ABC, the new one, by a factor of, we just figured out it was 2, with the center at point A, which means A doesn't move. I'm not moving A. If I'm dilating by a factor of 2, 1, 2, 3, 4. If I double that, it's now going to go out 4, 5, 6, 7, 8. 1, 2, 3 is now going to go up 3, 6. There's my new triangle. Now the last question says she translated it to get to the EDC. I mean, I didn't even necessarily have to draw all this stuff because A ended up moving to C. So they took this triangle and kind of slid it into place. P is how far to the right do they move? 1, 2, 3, 4. So they slid it 4 to the right. Q is how far down? 1, 2, 3. They slid it 3 down. And now I got put into place. Most questions on the geometry test are 1 point. Even if there's multiple things they're answering, a lot of times it's 1 point. This one was 2 points because, like I said, you could have figured out the K without worrying about the P and Q at all. So they considered that 1 point. And then if you figure out the PK, you get the second point. A lot of the proofs, which we haven't had any proofs so far on this one. The one we're doing, I think tomorrow there's a couple proofs, and then the new packet has a lot of proofs. Most proofs are 2 points, and it's kind of set up that you get, if you get at least half of the things correct, you get the point. If you get all of them correct, you get 2 points. So that's usually how the proofs are set up. So let's take a look at the next one. A company wants to design a cylindrical object. So I have a cylinder. Has a height of 10 centimeters and a volume of at least 2,000 cubic centimeters. So, on your reference paper, on the one side are all of your area volumes. I look for cylinder. Cylinder is V equals pi r squared h. That's my cylinder formula. Now they give us two different volumes. They give us a 2,000, they give us a 2,500. And we want something between the two. So we're going to actually do both of these. We're going to figure out the 2,000, figure out 2,500, and pick something between. So my volume is 2,000. Pi is still just pi. Radius is what I'm trying to figure out in the end. Squared times the height, and they said the height was 10. That's the height. So 10 goes here. So in that equation, I know everything but the radius. So I'm going to start working my way to the radius. I'm going to divide the 10 first just because it's the easiest to divide. So divide by 10. 200 equals pi radius squared. I got to move the pi out of the way, so divide by pi. So if I take 200, divide by pi, 3.14, I get 63.7 if I round, equals radius squared. Then, my last thing is to take the square root. So square root, 63.7, and I get 7.98. Equals radius squared. Now, that's as small as it could be. I want to pick a radius that's bigger than that, but not too big. Because I don't want it to get up to 2,500. So let's pick a number a little bit bigger than that, but not too much bigger. So pick a number. A little bit bigger, but not too much bigger.
2,900.
I'm trying to get the radius. So right now I've got my radius as 7.98. So I want my radius to be a little bit bigger.
Oh, 8.
So I can do 8. Let's try 8. So V equals pi 8 squared times 10. And as long as I'm bigger than 2,000 but not over 2,500, I'm good. So I'm just going to type it in. 3.14 times 8 squared times 10 equals 2,009.6. Yep, that would work. So 8 would work. I could have done 8.5. 3.14 times 8.5 squared times 10. It would have given me 2,268.65. I'm okay. I'm bigger than 2,000, but not too big for 2,500. So you just have to have a number that gives you something bigger than 2,000, but not as big as 2,500. That's what it's looking for. So there's actually lots of answers that can go there. You could have had 8.2, you could have 8.7. You could have anything up to, trying to remember how big it could go. The biggest it could go was 8.9. 8.9 was as big as it could get. 8.9 was still small enough, but if you went up to 9, you were too big. Questions on that?